Hello everyone. Welcome to the week 9 of our course, and the topic for today's discussion will be generating images through generative AI. Today we'll deep dive into the exciting world of making pictures with the help of AI. Imagine telling a computer what you want and it actually makes a picture for you. We'll explore cool tools like Midjourney, DALL-E, Stable Diffusion, etc. that actually do this specific task. These are like the wizards of the AI world, turning words into images that look real. Think of it as a super powered art machine. We learn how it works, how to use it, and discover the awesome things it can do. From making art to helping doctors, AI is making images that blow our minds. So let's get ready to uncover the magic behind these AI powered models. This is the notes which I prepared for this lecture. So let's go through them. Artificial intelligence has made significant progress in content generation, spanning from translating text into visuals to crafting intricate artworks and animation. This is particularly evident in image synthesis, where tools like Midjourney and DALL-E have streamlined the process. This is one example in which I used the DALL-E tool to generate some images. I gave it a simplistic prompt stating a skunk robot drawing a picture of a robot, and it returned me these amazing pictures. So we'll discuss about the generative AI models for image synthesis, their importance, use cases, and more. These are the table of contents, the topics which we'll be covering today in this discussion. So before starting with the image synthesis part, let's address the most basic question. What exactly are these generative AI models? So to state very briefly, generative AI is a type of artificial intelligence technology that can produce various types of contents, including text, imagery, audio, and synthetic data. The recent buzz around generative AI has been driven by the advent of large language models such as ChatGPT and BART, etc. But the concept of generative AI is relatively old. It was first introduced in 1960s, but with the introduction of generative adversarial networks, also known as GANs, the concept of generative AI became popular among masses. These models find applications in diverse domains like image, text, code generation, video, and music generation. So, having understood the generative AI models, let's have a look on what exactly image synthesis is. So, image synthesis is basically the creation of images from scratch. Generative AI models, which are a subset of artificial intelligence, craft novel images resembling their training set. They can enhance the quality of a low resolution images, making them appear expertly captured. Moreover, they are adept at combining portraits or deriving features for lifelike synthetic human faces. Commonly used models encompass various technologies such as autoencoders, transformers, GANs, etc. So, in order to create any machine learning model, the most basic fundamental requirement is a good data set to train the model. A model is as good as the data set on which it is trained. It simply follows the concept of garbage in, garbage out. If we feed the model with bad training data, then definitely the model which will be trained will not be a very efficient one. So, in order to train generative AI models, we need to have a very crucial site on the training process. These models heavily depend on the training data set to create diverse and high quality images. The dataset size must adequately cover the picture domain's variety, especially for fields like medical imagery, where illness, organs, and modalities are diverse. The labeling of the images in our training dataset should be correct, and also the quality of the dataset matters a lot. The dataset must be error free, artifact free, and unbiased. Biases can lead to the model to replicate undesired patterns in the generated images, and we don't want that. So, picking the right dataset is pivotal for a successful generative AI model synthesis. Once our dataset is selected, we'll follow certain crucial steps for the training of our model. These steps are data preprocessing, data augmentation, normalization, and data division. For preprocessing, uh, we tend to clean the data, resize, and format the images to a consistent standard compatible with the model. We also tend to augment our data because there might be cases wherein our data set is not adequate enough. Data augmentation um, simply means that we artificially increase our training data set by following some techniques such as replicating the images. We can artificially create new images from our original images by simply like rotating the images or cropping the images, resizing the images, changing their color schemes, etc. Using these techniques, we can increase the size of our dataset, which will help in efficient training of our model. Data normalization refers to the technique of scaling our data set. So basically, the pixel values, which typically range from the value of 0 to 255, we rescale it to a scale of 0 to 1. This helps in faster model training. And since our training data set is huge, in the case of generative AI models, we need to fasten the process of training these models. And once our data set is prepared, then we divide it into training and testing splits. This helps in the validation of our model and to judge how efficiently our model is performing. Now let's have a look on one of the generative AI models which is used for image synthesis very widely, which is Midjourney AI. Midjourney is an example of generative AI that can convert natural language prompts into images. In some cases, images from Midjourney have deceived experts in photography and other domains. The lifelike images which Midjourney returns are very astonishing and not easily replicated by other models. So, how does Midjourney actually work? Midjourney relies on two relatively new machine learning techniques, which are large language models and diffusion models. Large language model. Now, what is a large language model? So, we all of us have come across the ChatGPT model, which is designed by OpenAI. So, what is ChatGPT model? So, it is basically a large language model which is capable of understanding the human language and responds back in the same similar human language, which is easily understood by human beings. So a large language model is trained on huge corpus of textual data, which can be scraped from anywhere on the internet, from ebooks, etc. And they generally have billions and trillions of parameters. So, Midjourney uses a large language model uh, to understand the meaning of whatever prompt a user types in. Then, this prompt is converted into a vector, which we can imagine as a numerical version of the prompt. Finally, the vector guides another complex process which is known as diffusion. Now, what is a diffusion model? Diffusion model utilize the transformer architecture to generate data. As we can see in this image, so the process begins by taking a piece of information such as an image and introducing some randomness into that image over a series of time steps until that image becomes completely unrecognizable. Then the model attempts to restore the image back to its original form by removing that noise. This complete process of noising and denoising an image is known as diffusion. So, by performing these steps over and over again over numerous images, the model learns how to separate noise from an image, and these techniques are utilized by Midjourney to generate an image from whatever prompt a user has supplied to it. Now, after having understood how Midjourney works, let's see how can we use Midjourney to generate images for our prompts. So the first step is we need to sign up to the Midjourney. So this is the link. Let's follow this link to sign up. So this is the Midjourney homepage. We can see this sign in button here in the corner. Let's click on it. Since I have already signed in, so it has taken me to my account. And now we can see this button, join the Discord to start creating. Let's click on this. This will take us to the Discord of Midjourney. We have to accept the invite. Yeah, so this is the home page. These are some of the works from other users. We can see how astonishingly realistic images are being returned by this AI model. So to generate images, we can join any of these channels which says newbies, and here we can see this text box. We have to enter a prompt in this text box, and we have to provide the prefix of slash imagine. Yeah, this prefix will help us to create images from our prompt. Let's give it some generic prompt, bright sunny day. I'll hit enter, and most probably we won't be getting the images. Yeah. So since currently there's a huge traffic on the Midjourney's Discord server, so we'll have to subscribe to get the images as we need. But these are the steps which we need to follow. We can subscribe, and then once our subscription is activated, then we can follow this same steps and get the images as we require. Same steps have been mentioned in my notes. Yeah. Now let's move on to another very fascinating and very popular generative AI models in the field of image synthesis, which is called DALI 2. This model is also developed by OpenAI, the company behind the large language model ChatGPT. So let's see how DALI works. DALI is a state of the art artificial intelligence program which creates images from textual descriptions. Given a textual prompt, DALI generates an original image based on that description. The model has been trained on a diverse dataset of images and can generate wide range of images from photorealistic to highly stylized illustrations. So, at its core, DALI follows three steps using which it generates images. The first step is text encoding. So, the process, like in the case of Midjourney, here also the process begins by feeding a text encoder with the prompt, which converts it into text embeddings. The text embeddings in the case of DALI are produced by a separate neural network, which is known as CLIP, which is also developed by OpenAI. So, this is the functioning of the CLIP model. It produces encodings of both the image and the text and stores it uh, into a embedding space, and the distance metric which is uses to um, identify the similarities between them is the cosine similarity index. So this model, while it's training, it converts the text prompt and the images into the embedding space, and it continuously reduces the cosine similarity between the image and the caption pairs. Once this clip model is trained, we'll move on to the second step, which is the image encoding. And for image encoding, a separate model which is called prior, it is utilized to generate the image embeddings based on the text embeddings generated by the clip text encoder. The diffusion prior is a method that helps generate new image embeddings based on a given text description. This method uses a special type of machine learning model which is called a transformer, which is trained on several different inputs. After the image is encoded, we move on to the third step, which is decoding. For decoding, DALI uses another model which is called Glide, which is also developed by OpenAI. Glide's objective is to generate an image that preserves the key features of the original image based on its embeddings. Glide represents an advanced form of the diffusion model by incorporating textual information into the training process. As in the image, we can see the diffusion process wherein an image is taken and noise is continuously added to that image on different time steps. And then the model reverses that noise and learns how to generate images out of the prompts. And not only this, DALI 2 further enhances the glide model by integrating four additional context tokens, which we can see here in the image, into the output sequence of glide text encoder, which results in the ability to edit images through the use of textual prompts. So these are the three steps using which image is being generated from a textual prompt. Now let's have a look on how we can use DALI 2 to generate our images. So similarly, we'll follow the steps. This is the DALI 2's website link. Let's follow it. Yeah, so this is the homepage of DALI. We will, if you are a new user, you will have to click on sign up and then create an account. Since I am an existing user, I'll simply click on this login button, DALI, and yeah, this is my homepage. These are some of the samples which are already generated by OpenAI. So we'll just enter our prompt in this text box and hit the generate button to get the images. So I'll give a very generic prompt like professor teaching students on a bright sunny day. Generate. So under the hood, the generative AI model, which is being trained on huge corpus of image data, is being used, and we can see some of very photorealistic images have been returned by the model. We can edit these images, we can share these images directly from here, and we can also save these images either in the gallery, or we can like in save this to the collection, or we can also download these images. So yeah, this is how DALI works. Now, having learned how some of these generative AI tools like Midjourney and DALI work, let's move on to how we can utilize these models. Now, if you want to generate images for our personal creativity and for our imagination, then it is fine when we simply type in our prompt in the um, website of DALI or Midjourney, and we can get the one-off image that we need. But we can also utilize these models to maybe create an entire data set of a particular type of images, which can be utilized by some other developer or some other data scientist to train their model. In such a case, it is not feasible to type in a prompt one by one and generate millions of images manually. So, what we can do here alternatively is we can automate this entire process through a Python script. And this I have shown here with this example. We can automate this tedious task with the help of this script, and the credits of this code goes to AI Skunks. I referred to the AI Skunks repository, and I picked up their code and made some modifications and made it my own. So basically, what this code does is this code generates a series of prompts inspired by skateboarding scenes. So here we can see I have mentioned some brands of skateboards, some skateboarding styles, colors, and some themes and some riding styles. So basically, this code will specifically generate prompts related to skateboards. And you can alter this code to generate images of any object of your liking. Uh, so we are doing permutation and combination. We'll loop through all these different combinations here, and this is the prompt which I have predefined. Like imagine yourself skateboarding on a color, brand, and style, which it will pick from these lists which we have specified here, and then it will generate multiple prompts by encompassing all these elements from these lists. So basically, with a collection of these predefined scenes, including the skating styles, colors, and the themes, this code produces 100 prompts that allow readers to envision themselves skateboarding in a captivative setting. So these are some of the prompts. Let's rerun this code. Yeah, so these are the 100 prompts which this code generated. So we can simply now pass these prompts to the API of our generative AI model, and we can automate the entire process of generating multiple images. Uh, yeah, now let's have a look on this another code which we can use to implement DALI through a Python script. So basically, OpenAI they publicize their DALI 2 API, which means that we can call the DALI's API and generate images through our Python script as well. So to use the API, we need to sign up for the API key first from OpenAI's website. I have already done that and stored my API key in the Google Drive. You can also do so if you want to replicate the code. Once we have the API key, we can make API calls to generate the images. The API is a REST API, which means that we can make requests to it using the HTTP methods like get, post, and delete. So first of all, I am mounting my Google Drive because I have saved my API key there. Then this is the entire Python script which we will be using. So this code defines a class which is called DALI2 pictures generation that streamlines the image generation using their API. And then I have defined some methods like create image, create with download, actions, etc. These methods will be used to download the image, generate the image, etc. Overall, this class simplifies interfacing with the OpenAI API for generating and managing images, offering an efficient solution for developers. For example, this is the create image method, which takes in a prompt as an argument and creates an image based on the prompt. This method, which is called create with download, it takes in a prompt and an optional image directory and returns a downloaded image. And then there are some more methods. One method is called download image, which takes in a generated image and a directory path and downloads the image to that specified directory. So to generate the desired image, we'll pass on the text prompt as an argument in the create with download method, which we saw here, create with download. This will return us the web URLs for the generated images and would also download the images into our local directory. So let's run these code snippets. Yes, I will drive my Google, I'll mount my Google Drive, allow. Okay, so the drive is mounted. Yeah, and we can see here I have fed a simple prompt to it, a skunk robot drawing a picture of a skunk robot. Let's run this code. Yeah, so the images are generated. These are the 4 image URLs. Let's try any one of these. Yeah, so this is the image which DALI generated for us. So using this code, we are simply making a REST API call to the DALI's API and getting the images. It is similar to the task which we performed earlier, like going through the web UI. Now we are doing that through the API itself. Having seen the code, now let's discuss about some of the superpowers of the generative AI models. So, since we know that the model is trained on a large data set of text image pairs, it can generate diverse images with different styles and contents. Um, DAL-E or Midjourney or any other generative AI model for that matter is primarily used for image synthesis, which basically means creating new images from scratch. They can also be used for style transfer, which means we can feed in any particular type of style and we can ask the model to generate an image in that style. Let's try it out with an example. Let's see. Some famous painting paintings. Okay. Okay, girl with a pearl earring. Let's try it, this one. Mm, okay. So let's try Mona Lisa in girl with the pearl earring style. So the model tried to replicate the style of this famous painting, which is girl with a pearl earring. Similarly, in this example, we can see that we tried drawing the portrait of Mr. Beans in the style of Mona Lisa, which it very successfully portrayed here. Another very important application of the generative AI models is for completing some images. So DALI 2 can also complete missing parts of an image based on the surrounding context. For example, we can see here, I provided this image to the DALI model and I asked it to complete it with a doctor and a patient. So we can clearly see how well the model understood the image and extended the image to fill it with a doctor and a patient. It matched the color scheme and the objects perfectly and added the new objects in the image as requested. So this is one of a very fascinating power of the generative AI models. Now let's take a look on how we can use these models much more effectively. We can simply give them the generic prompts and they will definitely throw out some images, but that is not the most efficient way. Uh, Here are some tips on how to feed effective prompts to these generative AI models to get good images. First one is we should be clear and specific in our prompts. Uh, if we give a simple generic prompt like generate a picture of a car, it will throw some minimalistic images like these. But if we specifically define what kind of image we want, then we will definitely get some fascinating and very detailed images. Like when we give the prompt, like generate an image of a red sports car with a glossy finish and racing stripes, extra wide shot. So these are some very fascinating images which it returned, and it also paid attention to the phrase extra wide shot, as we can see in these images. So by adding more details to the prompt, such as the color, the finish, design, etc., these models can generate more specific images that match the expectations of users. Another very basic but very efficient tip would be to use very simplistic language and avoid any extravagant words because that might confuse the models. Uh, and yeah, we should definitely provide some context so that the model understands the prompt better. Like if we want to get a picture of a cake, we can simply give a prompt like generate a picture of a cake, but it might not return some very good images. Instead, we can provide a complete description, like this is the occasion for which I want this object, and then the model will definitely return some better looking images. Like in this case, we specifically mentioned that generate an image of a three tiered wedding cake with white frosting and pink flowers suitable for a wedding reception. So these are the images that perfectly fit our description, and the model was able to understand the prompt effectively. We can also give examples to generate our images. Like we can give the link of some image which the model will refer and generate new images similar to our examples. Like in this case, I added this phrase like generate an image of a house similar to this picture, and then I provided the Pinterest image link. So the model can like the model can understand the patterns from that image and give a image which is similar to our examples. And we can also iterate over and over again and refine our prompt to get a perfect image that we want. Like in this case, I started with the prompt generate a picture of a tree, where it gave me some pictures but I was not satisfied with them. So I then refined my prompt again and again, and this is the prompt which I ended up using. And these were the images which were exactly similar to the prompt which I gave it. Like I asked it, could you make the leaves more vibrant and the trunk thicker? So we can clearly see that the trunk is thicker in these images and the colors are also more vibrant. So these are some few tips which we can follow to make these models work better. And lastly, let's move on to some of the applications of these models for image synthesis. So these models have a wide range of potential applications in various industries, some of which might be art and design, advertising, product visualization, generating movies and video game concept arts, generating web designs, etc. And the technology is still new, and it's likely that creative individuals and businesses will find new and innovative ways to use it in the future. And we can clearly see that the applications are immense and incalculable, and this will definitely help in a meticulous way. Finally, after having gone through the entire lecture, this is the assessment quiz which I prepared. This quiz will help to assess and judge our knowledge based on the understanding of this topic. So, I urge everyone to go through these notes once again, and please reach out in case of any further comments or feedback. Thank you.